Inscribed Angles by Justin D'Souza. The learning objective of this lesson is to find measures in intersecting circles and prove relationships between circles. Inscribed angles. Here you can see a figure. There's a circle and there are two lines inside the circle, and these two lines join, that's the vertex of these two lines, are on the circle itself. Now this angle that is formed is called an inscribed angle. You can see the vertex whenever lies on the circle, then it is basically an inscribed angle. And now look at this angle over here. There's arc which is opposite to it. You can see it's in light green. This arc is the intercepted arc. Now it's very important to know what is intercepted. This is not intercepted. RQ is not. In these two lines, RS is not, only QS, because the arc, the intercepted arc, must have its end points at these two lines, wherever these two lines are touching. So that is an intercepted arc. This angle over here, the angle R, is the inscribed angle. Now let's look into a few of the cases of inscribed angles. You can see the first case here, this is also inscribed. It's on the vertex of the circle. The vertex is on the circle. It passes through the center. This is a diameter over here. This is not diameter, this is just two chords. This was one diameter, one chord. And this is, see, it's in one side itself of two chords, but it's within one side of the center. It's not passing both the sides. These are different cases. But whatever the case is, the formulas are the same. Now, first and the most important thing you must remember is, it's not central angles like what we had seen in the previous lessons. It's not central angle. Central angle means it will be from the center, right? Whatever was the angle over here and the arc is same in central angles. But here there is a formula. The angle formed is always the half of the intercepted arc. Intercepted arc is over here. The inscribed angle is always half of it. So now if you want to see over here, the angle 1 will be half of the arc AB. Or you can find the arc AB by multiplying 2 times by the angle 1. This is how we solve it. Now in this theorem, we can see this figure where two inscribed angles are there. You can see this B and C are inscribed angles. But look at the ends over here. What's happening? This arc that is there is same for both C, that is over here for this inscribed angle, and the B inscribed angle. So when the arcs are same for both, we must remember that these arcs, these angles are congruent. Because arcs are congruent, therefore these inscribed angles are also congruent. So we have this figure here. The inscribed angle over here is 40. And this will be the arc for the intercepted arc for this angle. And over here there's an arc given D. If you look closely, which will be the intercepted angle? It's angle C. But let's see, what do we want? Measure of CF. This is the measure of CF. So now we need to focus on this arc. So this arc belongs to this intercepted angle. So inscribed angle, sorry, intercepted arc, inscribed angle. Now this D over here, we know is 40 degrees. So how much will be this? We know this inscribed angle will be half of this arc, or this arc must be twice this 40 degrees, twice the inscribed angle. So you can write the exact formula, that is angle D would be equal to half of arc CF. Okay, the measure of arc CF. So over here we know this is 40, that is equal to half of CF, the arc CF. Take the 2 to the other side, it will be 40 times 2. That is the arc of CS or CF, or it's 80 degrees. So this intercepted arc is 80 degrees. Now we will move on to the next problem. It's very simple. Okay, there is one more question over here, the B question. Let's do it. Find the measure of angle C. Let's see this one. How do you find this? We can see the intercepted arc for this inscribed angle D is 98. So X will be equal to half of 98. That is equal to, 49. 2 less than 100. So it will be 49. So that is 49 degrees. So the answer is 49 degrees. That's how we measure it. And now we had the other theorem where inscribed angles are congruent if the intercepted arcs are same. Now let's look carefully for this at this figure. We need to find the measure of angle A. A and D will be equal in this case. Why? Because look at the points where the chords touch the circle. Both are touching at the same points. That means the arc formed is equal, right? So these angles are also equal. Now here then, we can just equate these both and find the value of x. Because phi x minus 2, that is the angle of inscribed angle A, will be equal to 3x plus 2. Now you can use the calculator and solve it directly, or let me just solve it up. This 3x comes to the other side, it becomes minus 3x, and 2r to the other side becomes plus 2r. Now here phi x minus 3 would be 2x equals 14, and x is equal to 7. But this is not over. We just found the x value, but did they ask x? No, they asked to find the measure of angle A. So what you need to do is put the x value in this equation. That is phi x minus 2r. Now we know x is 7, so phi times 7 minus 2r. Phi times 7 is 35, minus 12 would be 23 degrees. So this is the answer. Even over here, D also is equal, so it will be 23 degrees itself if you wanted D as well. This is how we solve it. The answer is 23. Now here, please do pause the video and try it by yourselves, and then you can continue watching the video where I'll solve the answer. Just like the previous problem, here we have again inscribed angles that are congruent because the intercepted arcs are the same. Now in such cases, we just equate the angles, that is 3x minus 5 will be equal to 2x plus 15. So take this to one side, the x's, the variables and the numbers. So 3x minus 2x is equal to 15 plus 5. We will get x is equal to 20. But this is not the answer. X is just a value. X is 20. We need to find the measure of angle T. T and U are same. So you can put in any, but let's just put in the T1 itself. It's 3x minus 5. X is 20, so 3 times 20 minus 5. It will be 60 minus 5. It's 55 degrees. That is the option number D. Now even if you do it over here, let's just do it over there. 2x plus 15, so it will be 2 times 20 plus 15. 2 times 20 is 40 plus 15 is basically 55 degrees. So the answer will be same because they are equal. So it's 55 degrees here. Now we will move on to a proving problem. Write a two-column proof given QR. Arc QR is congruent to arc ST. Okay, let's see QR, this arc over here. It's already mentioned in the figure. See, this arc, they have put a line, is equal to ST. And this arc over here, PQ arc with PT. Okay, that's fine. What do we have to prove? We need to prove that these triangles are congruent. That is PQR is congruent to PTS. How do we do this? So we basically have to prove it by one of this congruence theorem, that is SAS or AAS congruency. Let's see from the given what we can find. We need to follow the method over here. See, this is the statement. Let's see the statement, the reason. Now the first is always the given. You know QR and ST is a congruent, and PQ and PT are congruent. This is given. Now if this is the case, which are the angles that are equal? If arcs are congruent, then the inscribed angles are also equal, isn't it? So let's see over here. For this arc, this is the angle R. And for this arc, it is the angle S. Now we know this PT and PS is equal, so R and S must be equal. Similarly, over here for this arc, angle P is, and over here ST also this angle P. Now these both are also congruent. Let me mark it 2 over here. This is 1 mark. So they are all equal, those angles. So you can just write, you can, whatever the angle in consideration must be middle, or you can just write P and angle, it's fine. That's shorter way. Where over here QPR is congruent to TPS, and QRP is congruent to PST or TPS. It's fine, it's the same thing. If these two inscribed angles of a circle has intercepted arcs which are congruent, then those inscribed angles are also congruent. That is the theorem which we studied. You don't need to write it exactly, you can write in your own words. It's more than enough. And now we have what? Angle and angle. Now we need at least one side, this or this, then we can do angle side. Now we can't have this because it'll be side angle. You can do this side. Let's see, QS and ST, are they equal? Yes, they are equal. Why are they equal? Because you can see this part of the arc angle, right? If this part is cut by this chord, and even this is cut by this chord, and these two arcs are equal, so the chords must be equal, right? Because when the arcs are cut by the chord, the arc formed will depend on this. They both are in relation, right? So now this arc and this arc is same, so whatever the chord must be the same. So we can easily prove this side and this side is also congruent to each other. We know this angle is congruent to this angle is congruent to this, and this side is congruent to this. So we have angle side. Now obviously when two angles are same, this angle is also same, right? But now the problem is angle is not congruence, it's similarity. You can have two triangles with same angles, but they might be huge. Like, I mean, say for example, equilateral triangle, all angles are 60, and this is a big one. If the sides are not congruent, they have all angles equal, angle congruency is true, but the sides must also be equal, at least one side. Then we can tell, yes, not at least one side. In equilateral triangle, yes, at least one side. Otherwise you need to prove one of the proper congruency theorem. Now here we have angle side congruency theorem that proves that yes, these two triangles are congruent. Over here we know QS and ST because the congruent arcs have congruent chords, and then AS proves this, both triangles are congruent. Now we move on to inscribed polygons. Before we go to inscribed polygons, I just want to quickly remind you one thing. Please do subscribe to my channel. The reason I'm saying this is more than 90% of the viewers of my videos and everything are not subscribed. But I really appreciate the 10% who have subscribed. I'm so humble and I'm very thankful to you guys. Please, others, do consider subscribing. If you find my videos helpful, please do like them and also do share it with your friends. It would mean so much to me. Now, back to the inscribed polygons. Here, we are inscribing a polygon inside a circle. It's just not arcs anymore. This is a polygon. See, this is a triangle, right? Or you can have a rectangle or, quadrilateral, basically. Now here there are few rules that we can follow. For example, if a triangle is inscribed, especially in such case where this is the diameter. So what is the diameter angle over here? It's 180 degree. So this is also 180 degree arc because it's central. When it's central angle, it's different. So this is 180 degree over here, and this is also 180. But now if it is inscribed angles, we just now saw if it is on the vertex is on the circle. Now this one, which is far off, not the center, which is away, will be half of this, isn't it? Now this is 180. See, it's inscribing exactly at the center. So how much will be this angle? It should be half of 180, that is 90 degrees. Sorry, it should be 90 degrees. It should be a right angle. So this is one theorem. Whenever you see a line, inscribed triangle having the line as a diameter, remember this angle will be 90 degree. And then we can see inscribed polygon like this. It's a quadrilateral over here. Now in such quadrilaterals, always remember the opposite angles. The opposite angles means L and N, they are opposite to each other, right? And over here M and K, they are opposite to each other. They are supplementary. What does supplementary mean? Supplementary means when you add these both, it must be 180 degrees. So when you add L and N, it will be 180. M and K will also be 180. So this is about the inscribed polygons. Now let's look into those. We just now saw those theorems. Let's look into some problems and solve them now. Here, this is, diameter km. We need to find the measure of k. Now, just by looking at the figure, I know this is 90 degrees. Now, this is a triangle, right? If this is a triangle, I know this is 90. When you add up all the angles, what should be the answer? It should be 180. Or since I know this is 90, when you add up the two angles over here, it should be 90. Okay, but I'll do the easy method. Generally, students prefer the entire triangle is 180. So it's just add up all and equate it to 180. That means this is one side, that is 5x minus 4 plus here m is 8x minus 10 plus this is 90. This is the entire angles of all the triangles, all the vertices of triangles. So they must be equal to 180 degree if it's a triangle. Now you can put this directly in the calculator and solve, or we can also solve it over here. 8 plus 5 is 13x minus 14 equals, when you take this 90 to the other side, it becomes minus 90. 180 minus 90 is 90 itself. Now take this 14 to the other side, minus 14 becomes plus 14. So 13x is equal to 104. Now then we have to just divide 13 on both these sides. X is equal to 130 is 10 times 13 minus 26. It's 8 because 130 minus 26 2 times will be 104. Yeah, it's 8. X is 8. Now this is not over. We just found out x to be 8. We need to find the measure of k. Now remember, these both are not equal. Okay, they're not equal. So you need to put it in k itself. It'll be 5 into x minus 4. That is the value of k, right? Measure of angle k is equal to 5x minus 4. So I know x value is 8 minus 4. So it'll be 40 minus 4. That is 36 degrees. So this would be the answer. Final answer is 36 degrees. Here x is 8 and then substitute, you will get 36. Now please do try to solve this problem by yourselves and then we will continue. I hope you have tried this. If you tried this simple, over here you can see the figure is not so okay. Sometimes you might be thinking, oh, is it 90? If it's like this, I know it's 90. Whether this is 90. Yes, this is also 90 because this angle, the arcs over here, the line segments or the chords are touching the diameter. So whatever the angle over here is 180, so half of 180 will be, see this arc is 180, right? That's the intercepted arc is 180, so the inscribed angle will be half of it, 90 degrees. So this is 90. Now we can do the same thing, but I'll do another method because I know this is 90. Out of the total 180, I'll remove 90 and add these both equal to 90. That means 7x minus 5 plus 2x minus 4 must be equal to 90. Why? Because total is 180 and I know this is already 90, so remaining is 90. Now you just solve this over here. 9x minus 9 is equal to 90. When I take 9 to the other side, it becomes plus, it becomes 99 and x is equal to 11, dividing both the sides by 9. We need to find the angle, measure of angle V. So it's 2x minus 4. 2 times 11 minus 4 will be 22 minus 4. That is 18 degrees. So the answer over here for the measure of angle V is 18 degrees. This is how we solve it. Now we move on to the example 5 where we have a real world problem. Luca is creating a collection of stained glass ornaments. The ornament shown uses a quadrilateral inscribed in a circle. Find measure of F and measure of G. So we need measure of F and measure of G. Now we know for a quadrilateral, what's the thing? The opposite sides are supplementary, means 180 degrees, and these both are also 180 degrees. So what do we do is we just, okay, now we have this important thing. We have to just add them and make it equal to 180. I was about to tell you one more method. You can just add all of them. That will be equal to 360, right? Because quadrilateral angle is 360. But you can't do that. Look here. This variable and this variable is x, whereas over here it's y. So we have to do opposite angles only. So let me do D and F first. I know the measure of angle D plus measure of angle F must be equal to 180 because it's supplementary. So D is phi y plus this phi 16 plus F is 3y plus 4, that is equal to 180 degrees. Then 5y plus 3y is 8y plus 16 plus 4 is 20 is equal to 180. Now here take this 20 to the other side, it will be 8y is equal to 160 because it will be minus 20. 80 20 times is 8 2s are 16, so it will be 20 over here. Y is equal to 20. Now please remember here, this is not the answer. Sometimes once you solve this, this might be there in the option if it's MCQ exam and you might select it. Don't do that. Please make sure you substitute back in the angle F and solve for measure of angle F. This is just Y value, it's the variable. So now how do we find for F is, we know measure of angle F is 3y plus 4. Okay. Now here y was 20, so 3 times 20 plus 4, that would be 3 times 20 is 60. 64 degrees is the answer for measure of angle F. But we need to find for G as well. Let's do it quickly. So it's the opposite angles, 3x minus 16 plus x minus 4 is equal to 180 degrees. So add them up, it's 4x minus 20 is equal to 180. Take it to the other side, it'll be 4x equals 200 because it'll be plus 20. Now 4 5s are 20, it'll be 50 over here. X is equal to 50. Now this is not the final answer. We need to find the measure of G. So it'll be x minus 4, that is 50 minus 4. We get 46 degrees. So the answers are 64 degrees and 46 degrees. That's the final answers. The first measure was 64 degrees, that is for the measure of angle F. And the measure of angle G is 46 degrees. So there are the answers. These are the answers. And the last problem is a check problem. Please do try it by yourselves and then you can continue watching because I'll be solving it anyways. Even over here you can see the opposite angles variables are same. So x and x in the opposite angles, and over here y and y. Let's see what do we have to find. Part A is to find measure of J. So I need to equate phi x plus 2 equal to plus 8x minus 17, that is equal to 180 degrees. So add them up. 5x plus 8x is 13x minus over here plus 2 minus 17 will be minus 15, that is equal to 180. Now take this to the other side, it will be 13x is equal to 195. Now this is 130 plus 65, so it will be 15. X is equal to 15 because we know half of 130 is 65, so it will be 10 plus 5, 15. X is 15. What is the measure of angle J? J is phi x plus 2. Just substitute the value of x. So it will be 5 times 15 plus 2. It's 32. 5 times 15. My bad. 5 times 15 is 75 plus 2. That is 77 degrees. So the answer is C here. Make sure you can use your calculator directly because you're using scientific calculators. Here you can just put this in calculator and you'll get this answer. Even over here, this substitution directly, you'll get the answer. The first answer is 77. Let's do for the K value, measure of K. Now that means you need to just equate y, these both opposite angles. 11y plus 13 plus 12y plus 6 equals 180 degrees. Sorry for that. Hope it's clear. It's 6 over here. Now 11 plus 12y, this is 12y together. It'll be 23y plus 13 and 6 is plus 19 equals 180 degrees. Now take this 19 to the other side. What's going to happen is 23y equals 161. So now I know this is 230, it will be 3 minus 20 here, 10 minus 3, it's 7. So y is equal to 7 here. Now, how I did it is I know 10 times is 230, and this is 1, so I know it should be 3 times 9. 3 times 3 is 9. So 23 times 3, 130. If you just do that, you'll get it over here. So that's 7. And now, which is the answer? You need to substitute back in the measure of angle K. So it's 11 times y, that is 7, plus 13. 13, sorry. 11 times 7 is very simple. It's 77 plus 13. It'll be 80 plus 1 is 90 degrees. So this D must be the answer. Let's just take the answers over here. It's 77 and 90. These are the this is the methods to solve both these angles. It's very simple once you know what type of an angle is inscribed inside a circle. If it's quadrilateral, opposite angles are supplementary. If it's a triangle passing by the diameter, you know the opposite, the inscribed angle will be 90 degree. So know these theorems and then easily solve them up. So that's the end of this lesson. I hope you have found it helpful. Please do subscribe to my channel. Please do like my videos and share it with your friends who might find it useful. Until the next video, take care and happy learning.